Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 17 off the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got 1,024 players in the tournament. In each round, half the players are eliminated. We need a function that is best representative of that relationship. Okay. So what are we dealing with? Well, when we're dealing with the numbers decreasing by halves or doubling or by a certain percentage, that lets us know we're dealing with an exponential function. So y equals a times b to the x. That is our standard form here, and let's break down each term here. So this a is going to be your starting point, and so that's your initial amount. If we were dealing with money, we would call this our principal, right? It's the initial amount that is deposited into the bank, and then you have some interest rate that compounds annually typically. And if we were graphing this, we would say it is your y-intercept. Now, why is it the y-intercept? Well, because if you are graphing something like this, right, and we say, you know what, it crosses the y-axis right there. Well, if that crosses the y-axis, that means your x equals 0. And look back at our original equation. What happens if we make that exponent 0? Well, b to the 0 would simply be 1, right? And so that would basically eliminate it at a times 1. So really you're just stuck with a. And so that means that x equals 0 is going to be that a. It's going to give us that y-intercept. So that's a. Now b here is going to be your rate. If it's increasing, it's going to be called a growth rate. If it's decreasing, it's going to be called a decay rate. It's how it's getting bigger or getting smaller. And then your x, that deals with your steps. So typically it's a time frame, like every month, every week, but not always. In this case, it's not a time frame, at least not a traditional one like days, months, weeks, hours, or anything like that. So what are we dealing with here? Let's say f of x equals. All right, so we need a, which is our starting point, our principal, our y-intercept. Well, how much did we start with? 1,024. And then in each round, half the players are eliminated, right? It's a single elimination tournament. So we're just going to say 1,024. Which, not only does that make sense, take a look. That's every single answer point. That's not that difficult. The tricky part here is, what is our b, our growth or decay rate? Because that's what changes every time. Your x, in this case, happens to be rounds. So it's not necessarily weeks or anything. It's each round, right? Well, if each round, half the players are getting eliminated, right? This should give us a clue that the number is getting smaller. And take a look at this. Take a look at this. Since those are larger than 1, right? If you are greater than 1, it is actually a growth factor. You're increasing. If that b is less than 1, it's a decay factor. You are decreasing. And so we need a decay factor because if half the players are eliminated, it's getting smaller. So we're looking at 0.05 or just 0.5. What's the difference? Well, we're looking at half. Half. And what is our decimal representation of that? 0.5 or 0.50. So that's it. That's our decay rate. You can multiply it by 0.50 times x rounds. Then ultimately, you'd get rid of all your players. So here's our answer, B.